Hello. Okay, today we start simple probability. Let me fix this a little bit so it looks straight. Okay, so we are beginning our unit on probability, and today we're just going to start with the most basic, which is simple probability. Okay, so let's make sure we understand the vocabulary. Okay, so experiment. That's an investigation. Or a procedure with varying results. Like the results can be all different. So an example could be flipping a coin. The outcome is a possible result from the experiment. An example could be, what's a possible outcome of flipping a coin? Landing on heads. So you would write heads as an example of an outcome. Sample space, that is the set of all possible outcomes. And this we put in set builder notation, the wavy bracket. And so the possible outcomes for flipping a coin are you landing on heads, comma, tails, because those are the only two possible outcomes. Okay, so let's work on a couple of examples. If you're finding the sample space, so it says give the sample space and the number of outcomes for each experiment. A state that begins with the letter O. Okay, so we have, well, our neighbor, I can't make that curvy bracket this morning. Oklahoma. We have Ohio. And we have Oregon. Those are the only 3 states that start with the letter O. Another example of sample space is a day of the week is chosen. Well, we know there's 7 days in a week, so we have 7 outcomes. We need to list what they all are. So that's listing the sample space. So we would have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And yes, you can abbreviate. Notice my curvy brackets are just becoming just curvy little things here. Okay, just as long as I can tell it's not a parentheses or a true bracket, we're good to go. Now let's talk about probability. So we have to have the sample space so we can then find the probability. All right, so a measure of the chance of a specific event occurring, noted as probability of the event. I'm just making a recording right now. Okay, this is expressed as a ratio of favorable outcomes to the total number of outcomes. This ratio can be written as a fraction decimal or a percent. The big thing to understand is the sum of all possible probabilities is equal to 1. When I think of probability of something, it is what you want over the total. That's the way I kind of think about probability. It's what you want, what it's asking you to find over the total. So an example of this, we're looking at this spinner right down here. Let me move this up a little bit. Okay, we're wanting to find the probability of 9. So how many 9s are there on here? 1 out of how many sections? 16. So now we try, and we're gonna get to use a calculator for this. That's the fraction form, because we want the fraction, it's always in simplest form, a decimal and a percent. So in the calculator, I do 1 divided by 16, which gives me 0.0625. Now to change this to a percent, remember we have to move the decimal twice to the left. I'm sorry, to the right. Learn my right from left. 2 decimals to the right, and we become 6.25%. Now let's look down here. With these, it's at least, that means if it's at least, that means the smallest it can be is 12. So the probability is going to be any number that's bigger than 12. So we have 1, 2, 3, 4. Oh, but it says at least, so that means it's equal to. So we want numbers that are greater than or equal to 12 is what that's telling us. So there are 5 of those. 1, 2, 3, 4, 5. 5 out of 12. So we have 5 divided by 12, and that's going to be 0.416 repeating. So to make that into a percentage, if you hear something in the background, they're putting in my pencil sharpeners, and that's a-okay. Thank you so much for doing that. So we have 41.6 repeating percent. Okay, perfect squares. You've got to remember that a perfect square, an example is like 4, because the square root of 4 is 2. Not shaded, we're just looking at, so perfect squares, that would be 1, perfect square 2, 3. There's only 3. So we have, oh, that's not 3 out of 12. This is supposed to be 3 out of 16 up top here. I'm sorry, 5 out of 16. My boo-boo. So these are going to be different. So you got to pay attention to the numbers that you put. $31.25, which is going to give me 31.25%. So then we have 3 out of 16. Probability of not shaded. That's 1, 2, 3, 4, 5, 6, 7. So we would have 7 out of 16. 2 or 11. That means I want this one or this one. So that's 2 that I'm choosing. So then this is 2 out of 16. That's not simplified. So I have to take that down to 1 out of 8. This is the fraction form. And yes, you would have to fill out the decimal and the percent for all of these, but purposes of time, we're moving on. Okay. On the back, flipping over. Okay, we're going to come down here to talk about the complement of an event. The complement of an event is the probability of the event not occurring. So it's the opposite of the probability when you think about it. And since the sum of all probabilities in a sample space, sum of all probabilities is 1, the probability of an event not occurring is 1 minus the probability of an event. So if I'm looking at 8, it says if the probability that it will rain tomorrow is 3/8. So I know that the probability of rain is 3/8. What is the probability that it will not rain? So to figure out the probability for not rain, that's going to be 1 minus 3/8. Well, in order to do that, it's going to be 8/8 minus 3/8, which gives me 5/8. So that's my fraction answer. We've got to write this as a fraction, decimal, and percent. So handy dandy calculator. 5 divided by 8, enter. That's going to give me 0.625 and 62.5%. Okay, in your packet, you have to finish the notes and the classwork homework page, which is this one. Remember, you do get to use a calculator. The maze is extra credit for your 5P grade. Have a great day. Bye.